We are starting our first class in ES21 statics. So our lecture today is an introduction to the class. We're going to talk about classroom procedures and how to proceed through this class and what you can expect and what I expect of you. And by the end of the class, you will know how you are going to get the grade that you want so that you can move on to the next class that you want to take as well. And that is, of course, assuming that my computer is going to come up. So. All right. The first thing, since our Moodle page is a little bit slow, I'm going to access our syllabus for this class, and that way we can go over classroom procedures before everything's set over here. So when we do have access to our Moodle page, the first thing that we're going to do is to go over our class syllabus, and that class syllabus will be available to you on your Moodle page. And so as soon as it comes up here, we're going to take a look at the content of that syllabus and talk about classroom procedures, required elements, and how you're going to be able, what you can expect from me. This is very frustrating, and I apologize for this. This is I was in here an hour ago and everything was just peachy, but it's not peachy anymore. So this is still not up. You're gonna maybe something's coming up. I didn't think you were responding. What about Acrobat? Oh my goodness gracious. All right, let's see if we can actually do this. So looking at just a browser, everything in our class is going to be available through your student portal, which is accessible through the web address, the URL, my.nwc.edu. So this is my faculty portal, so it looks a little bit different, but the elements are the same for you. So one of the first things that we need to do this week before Friday really, is to make sure that you have access to your page and to make sure that you can get your emails and so forth, because everything that we do in this class, when we communicate between classes, I'll do through email, or if you come to my office, of course, that also works. But any official communication I'll send out through email. So on your student portal, over here on the right-hand side, you'll have the Moodle logo, and underneath Moodle will be all of the classes that you're taking that have an online or a stored component as far as Moodle goes. Now, when you access your statics homepage, what you'll see is that the first element that you can access is the class syllabus, which is what I'm going to go over today. The second element is the homework template. I'm going to access the course syllabus just through Word, just because it was kind of hard to get it. My Acrobat wasn't responding. So, but if you click that on your own computer, you'll have access to the syllabus. So we'll talk a little bit about how the class is going to work, and then if you have any questions, I hope you will ask me about them. But basically, this class is ES, Engineering Science 2110, Statics, and it's being taught in two different formats. We're being taught partly face-to-face and partly over the internet. Then also there's a fully online component. So what that means for you really is that all the content of this course will be available to you through the Moodle page. So I really like it when students come, especially because I record a lot of content by myself, so I talk to myself in this room quite a bit. So it's always more fun to have company when you're talking a lot. So I hope that you will come whenever you are available to be here. And I'll also be in the same classroom Friday and Monday at noon, and you're also welcome to come at that time. But you're not ever obligated to come as long as you're keeping up with the material, and I'll show you how to do that. And also, like I said, make sure that you work with me in between at other times if you have problems. So my name is Astrid Northrup, and my office is just down the hall, just 2 doors down inside of the main office for the Physical Science Division in room 117. And I've put my phone number and my email address on the syllabus. The best way to get a hold of me is almost always emailing. Our voicemail doesn't always work, and I don't always pick up my phone. So if you need to get a hold of me, please email me. And if I need to get a hold of you, I'll email you to your student account. So if you email me, I would strongly recommend that you email me from your nwc.edu student account, because a lot of times our spam filter will catch something if it comes in through Gmail or iCloud or something like that. So it's very reliable if you email me through your student email account. My office hours this semester are going to be between 9 a.m. and 11 a.m. on Monday, Wednesday, and Friday. However, I'm in my office all the time. And would you say, Tyre, is that a fair assessment? Am I there a lot? Yes. So anyway, we get to visit sometimes. But anytime I'm in my office, you are very welcome to come by, and we can work on stuff. And if you need some allocated time, like if you really feel like you need to have an hour or a half hour or whatever to just work alone with me, please just send me an email and we'll set an appointment. And that way, that time will be allocated to you, or if a couple of you are working together, and then we won't have to worry about interruptions from other people. So, so please use that. That's what I'm here for. So the catalog description for this course, it's a vector approach to the mechanics of stationary particles and rigid bodies. We talk about external forces, moments, frictional forces, and fluid statics. Sometimes we talk about fluid statics. The prerequisite for this course is Calculus 1. Now, if you are not finished with Calculus 1, you just need to make sure that we've had a conversation about what other courses you've taken that will get you ready for that. And you definitely need to, regardless of other prerequisites, you need to be in Calculus 1 while you're taking this course. So if you finish Calculus 1, you're absolutely golden. And if there's any other way that you've come to this class, just talk to me, or if we've already talked, that's fine as well. So generally speaking, statics is the first of the engineering science sequence that's required of all engineering majors. Now, there are other courses, like for example, you may have taken or will take ES 1000, which is Orientation to Engineering, and ES 1060, which is Engineering Computing. But statics and dynamics, which is the next course that many of you will take, are like the first 2 classical courses that engineers have taken literally since the 1940s. So if you know anybody who is an older practicing engineer or a retired engineer, they almost assuredly have had statics. So it's always kind of a conversation opener when you meet another engineer. So they may not know, they may not have taken engineering computing or an orientation class, but they definitely have taken statics. So what are our objectives in this class? We're going to understand vector mechanic considerations and apply these to non-accelerating engineering problems. Things that accelerate, the math becomes a little more complicated, so we study that in dynamics. So we start with things that either don't move or at least are changing in their rate of speed and their direction of speed. We also want to gain factual knowledge and terminology. We want to develop the thought process and methodology to interpret, analyze, and solve engineering problems to the level that we require of you from this point forward, and to present solutions in an industry standard format, all of which I will cover with you very soon in this class. This is just crazy. Tell you what. Okay, here we go. This is about to make me nuts. And it's all dead. Let's see. Okay, I want to see if I can access it here. Am I living dangerously? Oh, there we go. All right. So, so at least we have that. Okay. So we've talked a little bit about our topics will include vectors, forces, equilibrium, centroids, moments of inertia, fluid statics, trusses, frames, machines, and friction. And if you know what all of those things are, then you are too far ahead to be in this class, because that's what we're going to do in this class, is learn these things. The book that you need is called Vector Mechanics for Engineering, or for Engineers, Statics. And the textbook looks like this. It's the 11th edition. Now, the textbook comes in two different formats. Sometimes you can get a very thick book that is statics and dynamics put together. Sometimes you can get the thinner book that is just statics, and either one of them will be acceptable. This is not the newest edition of the textbook, so that means it will also be available to you through Amazon or through secondary booksellers. So if you can get one from them for less money, I would significantly recommend that you do that. So that particular edition was published in 2016. Now, in statics, it's quite possible, I don't look for a curve, it's quite possible that everyone in here could do extraordinarily well, and I would think that would be great. So if everybody gets an A or an A and a B, that would be super. And that has happened sometimes, so it always makes me really happy when everybody gets good grades. So the way that you get the grade that you want is to complete the elements that we have listed here. There's homework, which is worth 20% of your grade, and that's actually divided into two pieces. Every chapter has homework. That will be, we're covering 8 chapters, so there'll be 8 homework assignments that will be worth 10% of your grade. Then there will be 2 timed quizzes, non-proctored, open book timed quizzes that's worth another 10%. Then the midterm exam, which is a 2-hour proctored exam, is worth 40% of your grade. That will be about October 11th or October 14th. And then the final exam somewhere between December 11th and December 13th. Now, if you're here on campus, I would proctor those for you, obviously, unless you have a big conflict. So if you're gone during that time, we can arrange to have, a coach or a teacher or a librarian proctor for you. Otherwise, this classroom will set a time and we'll just take a test just like every other test that you've ever had in your whole life. So, but we'll do it one way or the other. The other thing I can do, and this is not just for the people here, but for the people who are out there in Cyberland, I can, if you find a proctor, if you have a teacher or the testing center at your home university or engineering college, that works very well. Or I can proctor you using a program called Zoom. So, and I can do that for anybody here as well. So if for whatever reason you're not here, we can proctor over the internet rather than face-to-face. All right, so if based on those elements you have a 90% to 100, you'll get a letter grade of an A. If you have 80 up to less than 90%, you'll get a B, and so on. Generally speaking, you have to have a C in this class to move forward, but really, especially if you're going to go to UW, and doubly especially if you think you'll go into mechanical engineering, you really need to aim at a B. The University of Wyoming has, in mechanical engineering, has what they call a success curriculum, which means there's a list of 10 courses, all of which you can take here, but it doesn't matter if you take them here or there. You have to get a B average in them to proceed to the next level of engineering, of mechanical engineering. That is not typical. But it's just something that I throw out there, because if you were to get a C in here and you wanted to be a mechanical engineer at UW, you'd have to get an A in a class to offset it. So always aim at Bs, and aiming at Bs is a good idea anyway. So, and there's no reason that all of you can't get a B. So that's the other part. Now, whether you are face-to-face with me or out in on the internet with me, all of your homework is going to be submitted through Moodle. And I don't accept homework like if you bring it to my office or email it to me, and it's purely an organizational thing with me. When it comes in to me through Moodle, it's all together and I can grade it all at the same time. And one of the things that allows me to do is to see if there's a misconception that a few people have, I generally know that I need to address that in class. And so if I can grade everybody's stuff at the same time, it's helpful to me, not only in terms of grading, but in terms of presenting class materials. So that's why I do that. Now, you can use a scanner to do this, or there's a program that's available to you on your phone, right?
Dropbox.
Dropbox. There you go.
Dropbox.
Yes. There you go. And there's one called Office Lens that has a scanner as well. So, but they're all free. You can do it right from your phone. And if you need help with that, we can show you how to do that. But make sure that by the time the first homework assignment comes up, that you're able to scan your homework. Yes?
I have a question.
Sure.
I did not quite get about the midterm exam and final one.
Yes.
So for example, should I find like somebody else to
No.
So
You just come see me.
And usually you have to proctor.
Yes.
Oh.
Yes. If you were gone, like if you had an exciting trip to make, if you got to go to Model UN in Washington, D.C. or something, then your sponsor or another teacher could proctor for you.
Okay.
But I prefer, if you're here, I greatly prefer to proctor the exams myself.
Sure.
Good question. Yeah, very good question. So the next piece of the syllabus doesn't really have very much to do with our specific class, but it's about Northwest College in general. Our ADA statement just says that if you have a disability, we're committed to making the classroom an accessible place for you. So if there's anything that I can do to help you, please let me know. And that might not even be a disability. Sometimes I have students who just there's just something that helps them be successful. I had a student one time that, for whatever, and I don't understand this because I'm not a support provider, but he had a blue transparent film that he liked to put over his work, and it made him be able to read it better. Things like that are fine, absolutely fine. Another lady who liked to listen, she recorded like little affirmations for herself that said, "You're a good student, you're going to do well," and she liked to listen to it on headphones. That's fine. Just let me know. Anything I can do. So a lot of people just need a quieter space. Like, this classroom is not going to be terribly noisy, but sometimes if we have a noisy classroom, that can be very distracting. So I can give you a space to yourself where you can take your test. But if there's anything that's going to make the mechanics of this class easier for you, please let me know. And we're also committed to non-discrimination. And there are several protected classes in Wyoming, and we respect them all. So if you notice anything that violates that principle, please let me know. And I want to make sure that everybody feels safe and comfortable in this classroom. If you are going to withdraw, if for whatever reason, and I hope nobody falls into this category, but if for whatever reason you feel like you cannot finish this class, please don't just quit coming. You need to go through the formal drop or withdraw process. And it's very simple. It's just paperwork. And I can help you with that, or you can go to enrollment services and have them help you. But if you just quit coming, you'll get an F, and it will stay on your transcript, and it will bring down your GPA. And it can be something that would be harmful to you in the future. So we just want to get it off your transcript so that it's a non-issue. So it probably won't happen, but if it does, let's go through the real process. Okay, the last part is on academic dishonesty. And basically, academic dishonesty falls into two categories. It can be either cheating or trafficking. So cheating is when you use somebody else's material to be more successful, and trafficking is where you give your work to somebody else to help them be more successful. And both of them represent academic dishonesty because it's not fair to everybody. We want to really level the playing field and make sure everybody has an equal opportunity for success. So, in my opinion, for this class, if you're doing your homework and you're working with other people, that is not academic dishonesty. I prefer it. I think you learn a lot when you work in groups, not requiring it, but it can be very, very helpful. So if you work with somebody else, and even if, let's say you have 8 homework problems, and one person does 4 problems and the other person does 4 problems, and then you exchange work, I still want to see all of the work in each person's handwriting. So if you take that and you work together even to that level, that's fine with me. Now, exams, on the other hand, are completely solo endeavors. So, and all of this really, I always tell my students, I usually don't have to tell engineering students this, but you know, it's never worth it to cheat. There's just a whole lot of penalties in place, and you can get an F on an assignment, you can get an F in a class, you can be removed from school, and it's never worth it. You know, I mean, and if anybody's ever like, I've had people say, well, I was embarrassed to turn in that test because, you know, you'd think I was a bad student. I'm just like, oh, trust me, you have not seen what I have seen. You will not embarrass yourself. If you do a bad test, I respect you for getting it off of the table and moving forward with your life. But yeah, so don't ever worry about that. That will never be an issue. I really think, you know, it's never worth it to cheat. Just take the bad grade and move forward, and everything will probably be fine. So the final exam schedule, I'm not exactly sure when our exam is here, but finals for us will be between December 11th and December 13th. So we will have a fixed time, and then if that doesn't work for you, we'll adjust. So that's the whole thing about this class. Being partly on the internet and fully on the internet, depending on who you are, gives us a lot of flexibility in terms of time. So if something doesn't work well for you, let me know, and we'll work around it and get you so that you're good to go. All right, so let's talk about homework for a minute before we move on and take a look at what our schedule is going to look like. This is a homework template that I put together just to show students what I like their homework to look like. And when I say like, I mean this is sort of like the equivalent, if you were in an English class, to having like 1-inch margins and double-spaced 12-point font. You know, yeah, yes, exactly. So I always tell my students, every engineering problem is an essay problem. So I want to see your thought process. And if you've been in a math class, sometimes you might have 50 or 60 problems in a night for homework. In engineering, you'll have 4 or 5. And it's not because it's easier, but it's because they're just longer. You know, they just take longer. So most people, because this is right in our wheelhouse to do the math, right? We like to skip right to here, but there's a whole bunch of stuff that we need to do first. You need to show me the setup. And so you would like restate the problem briefly. Then if it's appropriate, draw a sketch or a free body diagram. Tell me what theory or principle you're using, list any assumptions, and then do the math. Then at the last step, you write your answer, which is generally speaking a number plus units with about the right number of significant figures. I'm not a real stickler for that. It's not like chemistry class where you have to be exactly correct. But if it's 2 or 3, if your numbers are all 2 or 3 significant figures or 1 decimal place, give me an answer that kind of looks like that. You know, not 15 decimal places or, you know, yes. Yes?
Is it approximate than that?
Yes, absolutely. So just somewhere in the ballpark. So from an engineering point of view, almost all numbers are measurements. And so you have to reflect the answer to show how it was measured. So, and an example I might use for that, it's kind of a silly example, but like we use money as a measurement of wealth. You know, we don't really think about it like that, but when you say this really rich guy is worth $250 million, you don't really mean he has a room with 250 million $1 bills in it, right? You mean his stuff, his boat, his houses, and everything else is worth $250 million. But money is only measured to the penny. So it is, if I say I have about $100, that's a valid thing to say. Or if I say I have $101.23, that's also another valid thing to say. But if I said I had $101.62539, you know, what does that even mean? I know, it doesn't mean anything because we can't measure money out here. So that's what I mean by money. And if you're at the bank, they're always going to round you down. So anyway, so there we go. But you always have to think about the way things are measured. And so we want to reflect that we understand that we're not just doing a math problem. All right, so aside from that, you put the problem number out kind of to the left, the answer out kind of to the right, and then you separate one problem from the next. You do not have to start every problem on a new sheet of paper, but you need to show them separately. You can draw a line or you can just make a little space. It doesn't matter which. Then on the top of your paper, you need to write the date that it's due, not the date that you're working on it, but the due date. the course number, ES 2110 in this case, and the chapter or other indication of which homework it is, your last name, your first name, and then what page you're working on, and the total number of pages. So, and then, like I said, when we look at the course, you'll see it says here, this is when we cover Chapter 1. Now, Chapter 1 is quite short. It's a little bit of a review. Chapter 2 in this class is quite a bit longer. But I have a few of the due dates up already, and I don't have the assignments there. It's not complete. This is just a framework. But our first homework assignment will be due next Wednesday, so I'll be posting it before the weekend. And it's going to be a unit conversion problem. When you read through Chapter 1 in your textbook, it doesn't have any problems at the end, so I will give you a handout to do just to work with units a little bit. And then if you'll get some quadrille paper, like on the homework template, now it doesn't necessarily have to be green, but the kind of paper that you need to use has to have a quadrille background or a little square background. It's not ripped out on the left-hand side, and it's designed, it's got the blocks up on the top to put in information. Okay, so, and you can get that, I think you might, I don't think you can get it at the bookstore. I had a student check this morning, but I don't think you can get it there, but you can order it from Amazon, for example, and you should have it in time, and it's actually quite a bit cheaper if you go through Amazon.
There we go.
Yeah, so like this type of an engineering pad. And like I said, it comes in, yeah, it looks like, if you look at it up close, that's kind of what it looks like. It's got little grids on it. Doesn't have to be green. If you, like, sometimes people have an internship or they know somebody who's worked at an engineering company. Most engineering companies have this kind of like, it's almost like letterhead. They'll have like their little company emblem on it. And so you can use anything like that, any kind of grid paper. And if you don't have any before the homework assignment is due, please let me know and I'll get you some to get you started. Okay, so we'll turn in the homework when this is all finished. This button, there will be several lectures here that you can watch. You could rewatch this if you were interested. Then you can watch the lecture that I'll do prior to the weekend on unit conversions in the introductory material in Chapter 1. And then when you click on this submit button, there will be a list at the top. It's not there yet, but like right up here, there will be a list of the problems, or in this case, it will be an attachment to a handout to do some conversions. And then you can just submit through here. And then it'll let you know when you submit. Now, like I said, the due date it's not a cutoff date. So in other words, if you submit it late, it's not going to disallow you from doing that. If you're a little bit late, you're not going to lose credit. If you're quite a bit late, you may lose some credit. So just try to get it in a reasonable amount of time. But the submissions do shut off at 5 minutes to midnight. So I've had a lot of people who are playing chicken with Moodle, and they kind of got bit, because they didn't get it in on time. But I recognize that, so it'll be good. Anyway, so we have the Chapter 1 and the Chapter 2 things. Then we're going to have a quiz over Chapter 1 and 2, which will be online, timed, but not, it's open book, open whatever, it's not proctored. Then we'll do Chapter 3 and Chapter 4, and then we will have a proctored midterm exam. Then the last half of the class will look very similar to that. So everything that you'll need to be successful is going to be available to you on your Moodle page. And anything else will be available by coming to talk to me. If you have any questions or concerns, I hope you will feel very much at home coming to see me. So, yeah. Do you guys have any questions for me? No? All right. So I did not print off copies because I was vain, thinking that the technology would all work like a charm, and as you saw, it didn't necessarily. But the syllabus is available to you if you like to have hard copies of stuff. You can print that off right from our Moodle page. And aside from that, prior to the weekend, look for the second lecture, and I'll have the homework assignment posted for Chapter 1, and then I'll do another lecture for Monday of next week, and I'll be here Wednesday. Now, like I said, you are more than welcome to come to the class to record with me if you want, and I'll do that Friday and Monday at noon as well as Wednesday at noon, but you're never obligated to be here as long as everything's going okay. All right? All right, well, thank you for your time today, ladies and gentlemen. I will look forward to seeing you in my office or here in the classroom in the near future. So, and please do not hesitate to get a hold of me if you have any questions or problems. All right. Thanks, everybody. That's it for the day. There we go.